Probando, un, dos, tres, un, dos, tres. Aquí hay mucho eco. Tal por stop. Do we start again? No? Yes? You replay? Bueno, aquí al very, 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 very fast. Normal. No, no, se no entendió nada porque esto es un... Ok. We, we replay, but very fast. Eh, tampoco se te escuchó. We don't introduce myself. Okay. Uh, green cranes. Green cranes, well, it's an energy project in ports. Under the umbrella of the co-financing by the European Union, France, in a TNT project. And I have left in the presentation the motivation, the geographical scope that is quite important because three ports belong to this project, so we can contrast the results and interchange information about the methodology and the type of machinery and the type of ports where is applicable or not one technology on another. So this is an important advantage of the partners. In this project have participated a lot of partners, port authorities, technical partners, machinery manufacturers, university, and the terminal operators. So we have a global view of the problem. The general goal is reduce the emissions, save energy, but do it in a profitable way, in a sustainable way. So you can guarantee that the technology can be applied for the modifications. We can make a very beautiful theoretical project, but if at the end it's not profitable, nobody is going to implement it. Okay. The first step of this project is the mapping of the energy profile. Where is the energy? We will see in the case of Noatin where is the energy. The second point is find what is the best technology to apply with that map of energy and with it depends the type of machine you use. This is the most difficult part. Then in the second activity to evaluate what is going to happen if I change the technology. In the third part, that is something new, we test in a real machine the second point, the theory. You take, in theory, the best alternative is, well, let's try. And this is the most interesting part of the project because the paper supports absolutely every figure, but the real data will demonstrate or not if is viable or not the technology. In our case, we are going to try LNG in terminal tractors. It is quite difficult to try to make a test, make a pilot. Slovenia, Paul Copper is going to to monitoring in real time the energy of the terminal, and for the moment to ramping altitude, sorry, it's a rich packet with another motorization or another technology to save energy and emissions. At the end, we will report the results, the theory we correct with the pilots, and then we will make recommendation about what is and when you have to implement one technology or another. One important thing is we are not here to invent anything. We are going to take existing technology and in the industrial world and apply in the port inside a terminal. Well, this is the team, the coordination, the main goals, the planning. Okay. One important thing to start with a case. That is the cost case. 63% of personal cost, variable personal cost, the stipend. What does it mean? It means that all our effort in a terminal is save money with the operational and with the stipend. Nobody is worried about energy, that is only 7% in Spain, because the stipend in Spain is very expensive. It's the other personal cost, machinery is quite high, but not too much, others. So until now, nobody spent time in energy, in emissions, in energy, but energy was not a problem. So we have in our terminal machines with a huge motorization that consumes perhaps twice or 3 times more than what is really required. Why? Because 5 years ago, 10 years ago, the energy was not important. And it is very important. But also it's true that we spend every year in one terminal 7 million euros per year. So if we save 30% or 40% of this, it's a lot of money that can pay the investment. And also, if we do it savings emissions, we can make profitable the project or the main goals. The alternatives. Nowadays, we analyze how many alternatives we have, but at the end, we say you only have 3 alternatives, 3 real alternatives in the industrial world. Electricity, gas, and fuel. Yes. The cost per kilowatt, we can see here, is quite similar. This is the electricity, the blue one. The green one is the diesel A, the gasoil A with taxes. The dark blue is the diesel B, with less taxes, industrial diesel. And the red and the blue is the price of per kilowatt of the gas. So you say here, well, the electricity is quite expensive. Yeah, but the performance of the electricity is around 90-95%, and the performance of the fossil combustion of the diesel and gas is 50, 20, 25. So when you apply the motor performance, the energy performance of this, to transform the energy from the diesel to at the end electricity or torque, the figures change a lot. This goes down below the gas, half of the gas. Methodology. Well, at the end, this is a standard project. We have to look for the rentability of the project. When you are starting a new project or a selection, what I prefer? An RTG, an crane, an electrical crane, a gas crane, or a diesel crane. Well, the crane is the same, the motor is the same, the wheels are the same. So we take out from the equation and we only compare or we only study the difference between scenarios, 2, 3, or 4 scenarios. So you take the gap between investments, between the how much does it cost an electrical crane, a diesel crane, or a gas crane, the cost, investment, and the cash flow. And with the gap, you make the figures. So you don't spend time studying a lot of things, this machine or the other machine. No, the same machine with the same cost and only the difference. So the mistakes you make are quite small in the investment. And this is important because all figures that we are going to see is the gap, the delta, the difference between one election and the other. Another thing, to define if it's profitable or not, we have to use IRR, internal and net present value, NPU, and the payback. 3 parameters. Very important. We are looking for maximum IRR if we don't have enough money. If you don't have too much to spend, you have to look for the maximum IRR. As internal return. You have to look for the maximum. If you have a lot of money, then your goal should be the maximum net present value. In the middle, any solution is good, and is valid. You don't have to go to invest more than the point of the net present value. I will draw quite easy. The concept is new, but it is stupid. If in a terminal you don't have one machine, you have a fleet. You have 80 machines, and when you have to take a decision, and this is important, it depends number of machines of the combination of you take, the project will have a result. This will be IRR and a net present value. At this point, this is the work. The net present value start to go down. At this point. So we are looking with this parameter. We are going to play with this parameter continuously. This is the 10% of the work. To look for this point and this point. And between these points, we are going to move to take our decision. What we have to do? Or between this and this, every election is okay, but outside, no. And this is very important. What is the cost of the money? What our company wants? Our company wants 10%. So everything below 10% of benefit IRR, we don't want it. well, a lot of people working with us in this project. In the Atom project, have worked a lot of companies and share all the information. We have this. Okay. Another important thing, the most important thing, the financial aspect. And the second one, that I will spend a lot of time with the financial aspect. And the second one is the concept that we have a fleet, not one track or two tracks. We have 80, 90, 100. And RPGs, the crane can move over the yard, we have 60. So it's not a decision of what I'm going to do with one machine. It's the decision of what I'm going to do with my fleet, with the 80 machines, or only 50. Perhaps I can change only 10. 10 one technology, another 10 another technology, and the rest another technology. Well, because we are working with a fleet, we have to know the life of that fleet. When we have to renew the machine, are you going to change or to revamping a machine that in 1 year it will be completely broke? No, it's stupid. I'm not going to electrify a machine, then the following year I will be completely break down. So the first work that we did was make the renewal plan for all machines. That is something relatively new, because in the ports nobody knows how to do, because nobody knows how long is the life of one machine, because nobody knows how is the cost along the life. What does it mean? When you have a new machine, the production cost, that is the summary of the consumption of energy and the cost of the stevedore and the cost of maintenance change. When the machine, typical, the life could be 50,000 working hours. With a truck, terminal tractor could be between 40 and 50, and with a crane perhaps 70 or 80. When the machine is new, the cost is really low. In warranty, everything is new and no problem. It increased quite fast and arrived during several years in this area, an horizontal way. And when it's close to the end of its life, the cost increased very fast. Why it happened this? Because in the middle, this is a fleet, the cost of the fleet, not one truck. The blue points are real data, and the black line is the interpolation. It's quite bad here, quite good here. But the correlation is regular. But the fleet, at the end, the behavior of the fleet is this line. What happened? At the beginning, the machine new, no problem. Then you start have problems with only few things, always the same few things. The gear, the motor, but simply it's always the same. When the machine arrives 50,000 euros in terminal tracks or 70,000 euros in RPG, start with big problems, structural. Move more, and then you have problem with the wheels, you have problem with the shaft, you have problem with everything. So the cost rise a lot. Well, when you have to change the machine, when the differential net present value between the decision of if I change the machine every year, every 2 years, every 3 years, every 4 years, is maximum, and that is this graph. And it depends basically how many here in horizontal we have how many hours works per year that machine, and in vertical we have years. And the conclusion was quite funny because the results were very similar than in every terminal. So if a machine doesn't work, you don't have to change the machine never. It's cheaper keep that machine and spend a lot of money in maintenance than pay to the bank the 10% of the cost of the money. The money is not free. If I want to buy a new machine every 10 years, the money costs. And what is cheaper? Pay a new machine for the cost of the money or save money with maintenance? So we have to compare our positions and get the maximum, the optimum point. And this is very important because this concept of how many hours does the machine work per year happens with everything. With do we have to electrify or LNG or change the machine? It depends how many hours works the machine, always. In the renewable plant, it's the same problem. When you have to renew the machine, the first question is how many hours per year works the machine? Because that cap of price is going to pay the cost of the money of the new machine. That is a lot, 10%. For example, this is very curious. A machine that works all year, you have to change the machine in 5 years, in 35,000 hours, terminal tractor, and works 22 hours per day, every year, working all day. Instead, the typical terminal tractor in a terminal only works 3,000, 4,000, and then you have to change it, I remember, 45,000 hours or something like that. 10,000 hours later. That is, pues, in one case, I remember 5 years, in the other, 12. The machine is the same, but in one case, 5 years, and very quite early, only with 30,000 hours, and in the other, with 45,000 hours later in time, but in working hours also. With the projects, always happen the same. What is the best selection in energy? It depends how many hours works the machine. And this is the concept that I was explaining. We have a fleet. This is very, very, very important. It's the base of our decision. When you have a fleet in a terminal, your terminal is never full, and your terminal is never empty. Sometimes you have a distribution, a distribution of the load of the workload. The blue graph, the first graph, what does it mean? Here, below we have in the xi, no, y and x and y, number of shifts that a machine, there's the horizontal, one machine work. So in Valencia, 1, 2, 3, no, 5. The minimum machine working per shift is 5. That works, I don't remember, 100 hours. We have working 5 machines, 100 hours. Only 5, and we have 80. But in one shift, in 10 shifts, only work 5 machines. During the year, we have how many shifts? 1,000. 1,000, I remember. So the one shift is 6 hours, okay? And you have 4 shifts per day. During the year, every shift, you select how many machines are going to work, because in the vessels don't go 10 vessels every day or every shift. One day comes 1, another 8, and the following 2, And then you have to adapt how many machines are going to work and how many people. So very, very important to understand that sometimes only works 5 machines and another works 80. So the equation is funny. If you are going to change the technology or select another technology to work, you have to understand that it's not the average of the working hours the best figure. The average of the working hour is one result of the equation. If I I if I change a machine from diesel to LNG, and that machine works all days because one machine can until 4 machines can work every day because this shift works 4 machines, but the following works 5 machines. The first 4 plus another one, and the next works 7 machines. The first floor, the order of the other one, and the distribution. If you summarize everything, you have some machines that could work every year and others that only works one shift per year. That is not true. In a real situation, you balance your fleet to work more or less the same, but that is not true. The real situation is that you have new machines and old machines, and you have people that say, I don't want to work with old machines. So the old machines only works once per year, or 3 times per year, okay, or 4 times, something like that. And the new machines works in this area a lot, always. And that is very important. Why? Because if I have to select, if I have to convert my fleet, and I make the first figure, that is, I change all my fleet to gas, okay? Or electrify all the RTGs, we will see the results. The cash flow that generates that investment will be the average. But if you only electrify the machine that is going to work every day, or the machine that can work every day, because you have the machine have work to do, you will obtain the maximum return of the investment. So that graph, the graph one dimension, 1D, show us what happens if I convert 1 track, 2 tracks, 3 tracks, 4 tracks, 5 tracks from diesel to gas. At the beginning, because you have to pay the gas station fixed cost, the profitable is negative and the net present value is very low. Then you arrive to a critical mass. You don't earn money, but you don't lose money here when you close the zero. But you need at least 10% of work. So you arrive to a critical mass, the minimum fleet that you have to convert to make viable the investment will be marked by when the IRR is equal to 10% to the work. And this is very important. Then you reach a maximum that should be the amount of fleet that you have to convert, and then go down. Why? Because you are wasting money in machines that are going to work only a few days per year. You waste perhaps 100,000 euros in a machine that doesn't work. Okay. This is quite difficult when you have 2 dimensions. When you are talking about electrification, you have the machines and the bus bar or the cable reel or the infrastructure. That one part is in the ground and the other is in the machine. So you have to make a combination, and it's quite complicated. Well, here I explain everything. When we studied alternative, we conclude that we only have one alternative to the terminal tractor, that is LNG, gas, because the cost is the highest of the cost of diesel and resolve a lot of problems with emissions. Well, this is the solution that no one. In terminal tractors, we spend 2 million per year in diesel. And you have well, three solutions. New motor, new diesel motor with a new technology, or LNG. The old motor, the new motor, and the LNG. And when you're talking about RTGs, that are the trains, you have more options. You have continuous with diesel, with different type of motors, smaller, bigger, new generation motor, transform to LNG, or go to bus bar electrification. Bus bar electrification are bars where the machine connects, and a cable electrification that is un enrollador. Okay? In this case, you are completely connected to the plug. In this case, you can connect and disconnect. In this case, you need to supply LNG to the machine because the machine is very big and cannot move to the petrol station. And the other case is the same than now, but with new motors. And obviously, this is an existing model. Also, you have to study how are you going to supply electricity to the terminal. And you have several tariffs. In the case of Noatum, you can buy the energy to the port, or you can buy the energy in two types of tariffs to the company, electrical company. Well, energy, more funny, more interesting. The real world. The real world that we have a terminal tractor, it's like a tractor, like a truck, but special, very hard, and with a well, quite a small motor, but it's prepared to work in a heavy way. If you want LNG in a tractor, well, the first option was gas, compressed gas, but it is available. Where do you set so huge amount? The terminal tractor have to work 24 hours without stop. So it's not a solution, the compressed gas. The solution was the LNG. That is, you need twice size tank than diesel. The other problem is the gas station. You need a new gas station that is quite expensive. $500,000 cost a gas station. Then, this is the funniest part of the project. So I have a machine that is able to work when you knew 7,000 hours with a cost, and then when getting older works less, you have problems, have to go to the workshop to repair and those things. And when it's very old, impossible, it doesn't work. Plus, I have a service life. I have to select when I'm going to take out a machine. That in the case of Noatum, because the type of traffic is 45,000 hours, the life of the machine. I have a type of traffic. With these three things, I can program a simulator that simulates how it's going to work, and we can see on the right how it's going to renew the machine, the fleet. The red figures are when a new machine is bought. So the rows, the columns are there, and the rows are the number of machines. So here in the middle, I buy a new machine, and then start to work there. On the right, we have how many working hours are going to make that machine. So if I know along the time how many hours is going to work a machine, I will know the cash flow, the savings, the savings in energy and the savings in cost. I summarize everything and I have a business case. This looks easy, but it's not. Simulate a fleet is quite complicated. And we have made a lot of simplification to get that figure. And it's quite different the results between make a rough number. The machine will work 2,000 hours. That is not true. Because the machine starts working 7,000 hours and at the end of its life it only works less than 1,000 hours per year. And the money that you gain at the beginning have more value than the money, the cash flow that came at the end 8 years later. So when you simulate the fleet, you get a good approximation of the final business case. And this is the result. The results, and it's similar in the most of the board, is that you need at least 13 units, the critical mass, to convert your fleet or to have a fleet of LNG in a port. It depends a lot of the traffic, but it's around 20, 15 units. If you are going to make less, if you are going to have less than 10 units of gas, it's inviable. You cannot do it. And if you don't have traffic, you cannot do it. And if the gas is very expensive, you cannot do it. And if the gas is very far away, you cannot do it. So you need a lot of conditions to make viable and to make profitable a gas project in a terminal. I say that the most important thing is have to be a busy terminal, and the second one is you need at least 15 units, preferably 20 units, to make profitable the project. Then no problem, it will pay everything. In the case of NATO, the decision was quite easy. If we are going to check if these figures are right with a pilot test, and then we are going to buy 20 units. If the pilot if this model is right, and we are going to verify with the pilot test, then at least 20 units, and the rest of the fleet as much as possible. In RTGs you have four elections. The motor is set a new genset, a new motor, diesel, but smaller, better. The LNG, chain and tracks, and the electrification. When you are going to electrify, it's quite complicated because this is the network, the infrastructure. This is fixed. Then you have to connect the machine to a post bar. This is also fixed. And this depends how many machines are you going to set. You have two types of way to connect the machine with the RTG with the electricity. One is bus bar. It's quite new and I like it because it's flexible. You can connect and disconnect quite fast. And the other is the cable grid, enrollador. That is very reliable system and works very well in automatic terminals. And it's the adequate solution if the crane have not to change the block, the block continuously. Also, you have the option of recovery the system. Well, what happened and what have to think? When you are going to electrification, we are going to talk about electrification. when you are going to electrify the machine, bus bar is only the 25%. It's nothing when you have to change the machine. The main cost is in the bus bar and in the infrastructure. So the problem in electrification is not the bus bar or the system, doesn't matter. The problem is how many meters are we going to electrify? Not how many machines, how many meters, how many blocks. This is the energy consumption in Valencia. If I'm going to electrify my terminal, I should start with the blocks where we have the maximum consumption of energy. If here in the green blocks we don't consume energy, don't electrify this block. Start with the red blocks, for taking area, say other people, and then go to the orange, and then go to the green, or it's the same. A group the red blocks in the middle or in one side, electrify that area, and don't electrify the rest, because it's the way to get the maximum benefit of the investment. This is quite stupid, but when everybody comes to electrify my terminal, I always say electrify or nothing. No, the best solution is in the middle. Electrify the most busy areas. This is the result of a model. Another model, it was very complicated to build the model. How many hours work a machine in every block? Well, when you make that, you obtain that in the case of Noati, if you electrify, I don't remember very well, between 25 machines and 24 blocks, you get the maximum benefit of your investment. If you electrify all the terminal, the maximum is 25% of IRR, and if you electrify all the terminal, you only get, I think was 12 or something like that. So if I'm a shareholder, I always put my money in the 24 blocks, not in the rest. Okay. Infrastructure is part. Between the substation and, well, the main substation, the new cable, the new network that you have to make, because what's the problem? The problem is that perhaps, no, the most probably thing is that you don't have enough power in the main substation of the terminal. You have to break all the floor, to break a new network to arrive every block in the yard. And then perhaps this arrive here in 20,000 kilovolts, and another 20,000 kilovolts cable that could be 1 kilometer, and then a new substation that passes from 20,000 volts to 500 volts. And this part is as expensive as the bus bar. It's very expensive and determines if it's reliable or not, the electrification of the terminal. Because the bus bar costs always the same, 400, 450 euros per meter. but the network, the net, the electrical net of the terminal changes a lot. Sometimes it's quite cheap, but the most of the time it's very, very, very expensive. And that's the reason everybody forgets the cost of the substation and the cables, and they are very, very expensive. Okay. What happened in I don't know if you can see in my terminal, the substation is here. If I have to supply in the middle these blocks, I have to make a new net. This is the net from here to here, and this is one and a half kilometers. It's quite big, and you have to break everything to do it again. In a new terminal, that cost used to be a half. You don't have to break anything. So at the end, we will see the new terminals used to electrify everything, and the old ones not so easy. So you have sweet point in all terminals. In all terminals, it's very clear that you only have to electrify used to be half of the terminal, not all the terminal, and get the sweet point. And this is another way to look the map of the investment. It's very clear to see that how we have an area that's here in the middle, the terminal, that is very interesting to make investment. But we have to move between the sweet point of the net present value, that is the graph that is below, and the sweet point of the IRR. So to move over here, it depends how many money have your company. You don't have too much to stop here, and you have no problem with finance, go here. But past this point, you are investing, you are electrifying a block or a machine that it doesn't return the 10%. So the net present value goes down. That's right. Another case. Well, this case is no atom case. Okay? And it's profitable. Why? Because the machines are quite old. Fantusi machine drinks 28 liters per hour. But the new machines in a new terminal, new terminal with new machines and very last generation RTGs, the consumption is quite low, 15, 14 liters. It's the half. So if you are going to electrify all terminal with new machines, it doesn't make sense because this is the case of Noatu. It will depend the amount of energy per meter that we move. In the case of Noatu, we have a very big yard, so we move per meter not too much energy, and it's not profitable. And what happened with cable reel? Cable reel, have here the results, is also profitable, but only in heavy or heavy works blocks. In the rest, not, because it's less flexible. The cable reel is not flexible, so I have to be sure that the machine is not going to move from 3 blocks. It will be working in 3 blocks because I cannot connect and disconnect. The cable reel is a good solution for automatization. And the cost is similar than the bus part. The cost is the same, but one technology is more adequate than other. It depends the use, and it depends the number of movements per meters. That is similar. Another solution, well, remember these figures. If I electrify, I get from my mod 25% of IRR. And what happens if I change the motor? We have to understand that in Noatu, we have very old machines. So we have a few motor and with very bad performance. And what happens if I take out that motor? I recalculate all the machines and I set a gen set instead of 600 kilowatts, 400 or 55. The machine will work lower only in the peak, only when rise a very heavy weight. The rest, the machine will work exactly the same. And uh, and the cost of set a new gen set is very, very cheap. So we make a figure. This is the theoretical part. And the return of investment, I only spent 2 million euros, and I spent, the machine consumes a half, 50 liters. So if my company say, well, it's very clear, 44% of IRR, half of emission, half, because the consumption is the half, or 58%, it depends the size of the motor, a lot, it's very good investment. Or this selection, what is the best? Quite easy. Set a new gen set. In my specific case, but what happened in other terminals? The most of the terminals of the no, well, frankly, I have the idea of what happened with the rest of the terminal. When we are talking about environmental, the electrification is the solution because in ports the cranes only works at maximum power when rise the load. The rest of the time, the machine doesn't work. Waiting or move from one side to another, the consumption is very low. So the performance of a full electric machine is very, very high, 90, remember, 92 or 95%, I might have seen. Electrical is not here, the performance. 95% of performance. Again, and on the other side, we have a diesel machine that only have 20%. So the emissions, the cost is similar, the emissions are similar, but the performance is not similar. So if you have a new terminal or a new machine, or you have the choice, the best solution is clearly electrified. When you have a machine that works a lot, only a moment, and the rest of the time doesn't work, it should be electrical. Environmental point, economical, and everything. The problem of the electricity is that the cable is very expensive. So, the first thing, imports. The energy is not important. The problem is the stevedore. So, it doesn't matter what are you going to do, but the most important thing is be careful with the operation. Don't implement a technology that stops the terminal or go slower. Always, the most important thing is don't start operation. The second point is if you are going to make a refurbishment, don't do just to most important in the most cases, don't do everything. You have to think where is the sweet point and the gap, the difference between the sweet point and everything. I want to electrify everything. No, it's huge. When we start with this project, the first thing we see we study was electrify the terminal, and the conclusion was it's not reliable. We are not going to do it. But when we study again the sweet point, it wasn't reliable. We can't do it. If I electrify the half of the terminal, perfect. It's very interesting. In the terminal, we have fleets, not one machine. You have a lot of machines, and you have to think in a fleet way, not in a machine way. You have to think a machine is a machine, but you have to manage a fleet, and it's not the same. You have to think in a different way, and you have to make the figures in a different way, and always the same. Green, okay, green is fantastic. We like a lot the word green, but if you have green and your IRR is below work, forget it, because nobody is going to implement that technology. At the end, stakeholders is the boss. And I want every year 6% of my money. If not, I take out the money. In everything, in favor, the solution for the terminal offers too. In favor, you need at least 15 units, and we don't have experience with that. It's a new technology. When you are in the real world, you always have to test the new technology. If I get crazy and I say, we are going to start with an LNG in all my terminals, all the fleet. Sorry, you will lose your job. Because this is not so easy. The LNG, we have a lot of buses here in Madrid with gas. In Spain, half of the rubbish trucks is gas. But the terminal is not a bus. And the terminal tractor is not a bus. The main difference is the driver. In one case, it's a professional driver, and in the other is a stevedore. And a stevedore is very, very, very special. And you never know what is going to happen. And this is a very heavy slide. Well, what happened with the electrification? Oh. Electrification. It depends. We have so that the investment is permitted, and the return of the investment is also permitted. The movements are not in the machine, are in the flow. So in horizontal movements permitted, in vertical IRR, benefits, incomes, profitable. If you don't move anything, you spend a lot of money in an investment and the return is nothing. So you start over here, very low, very low. And here I think is the red light. I will start with 50 movements per meter. In the slide here, 50, 0, to start like this. I'm going to draw the IRR. Then you need a critical mass to don't waste your money. That is around 50 movements per meter. But it's 0% of IRR, and our stakeholders ask 10%. So at least you need 180 movements per meter. It depends the price, the gap price between diesel and electricity, and the cost, and it depends a lot, the cost of the infrastructure, the substation and the cables. but it's around 150. It could be 150 or could be 200 movements per meter, but it's around 180. So, and this is the critical mass and the critical point. If you have more movements, then it's very, very interesting. And what happened with the sweet point and the and making all the terminal. This is the graph of sweet point, and this is the graph, quite parallel, of whole terminal. To get the critical mass, if you electrify all the terminal, you have to go a lot, very, very, very far away, 300 movements per meter, in average in the terminal. What happened? And that is the most important thing when we are talking about electrify a terminal. It's quite easy. Only the blocks that have more than 200 movements per meter are profitable. There's no. So, in average, in the terminal, 200 was, yes. In average, in the terminal, you need, no. This is my 200 or 250. Sorry, my apologies. You need 300 movements per meter in a block. Movements per meter in a block to make variable. In average, the terminal has only 180, 200. But these blocks, the sweet point blocks, move more than 300 movements per meter. Because we have busy blocks and not so busy blocks. So I make a simulation with my terminal, with my distribution of load of work in my terminal. And what is going to happen in my terminal if the traffic increase? Well, that the sweet point move to electrify more blocks. But it's always in the same. Electrify all blocks that are over 300 movements per meter. That's right. I have to review the figures, but that's right. So in average, the terminal we have 200. And that is the most important part. If your terminal have less movements per meter, then your terminal is your yard is not very busy. And the best solution is not electrified, is go to a small motorization. You need a small genset that small enough, not too small because it can affect the productivity, but enough to don't affect the productivity. And nowadays that is between 350 kilowatts and 400 kilowatts of genset. A genset of 400 kilowatts. That is quite small for that train. Better 350. That is nowadays 13 liters of motorization. So if I have a spread yard, then more motorization and more machinery. And if I have a very heavy yard, a small yard with a lot of traffic, and the blocks are 5/4, very tall blocks, then electrify. Big number. A terminal that in average is too high, dos alturas, too high, 2.5 is the limit to electrify. I believe no. You need at least 3 heights. And if you have an average of 3 or 3.5 height, then you have to electrify. If you have a lot of height with 6 days of 10 over, then you move a lot. All the big terminals in Spain that are saturated in Spain and in the Mediterranean should be electrical. And the terminals that are empty is shooted. Quite easy. And Valencia is in the limit. Our terminal in Valencia, that is very big, is in the limit because have a very big yard. But in a standard terminal, with the traffic that we have, we should electrify the yard. And that's all. That's the conclusion. This is the most interesting part. Question. The emissions. The tier 3 doesn't have urea tank and was urea tank and the catalyzador. This is the technology. And the tier 4 needs urea tank, that is quite expensive, I need urea, and special injector and catalyzador, scrubber, yeah, scrubber, I don't know, forget. That is a special one. And a few things. It's technical. It's quite expensive. The tier 4 new motors that will be available in 1 or 2 years are quite expensive. As expensive as gas motors. So nowadays, if the gap of price that we have is quite big because we don't have a gas LNG tractor, it makes sense. But in 3 or 4 years, all terminal tractors will be gas terminal tractors, sure. Because the gap price between the gas terminal tractor and the new diesel tractor will be nothing. It will be the same. And the gas is 50% of the price than the diesel. Nowadays, a terminal tractor costs 85,000 euros. One terminal tractor, one diesel terminal tractor costs 85,000 euros. And one gas LNG terminal tractor costs 35,000 euros more. It's a lot. But in the future, in 5 years, the cost will be exactly the same. So it's very clear. If the cost is the same and the fuel costs half, all the tractors will be gas tractors. Or that's the reason we bid for gas tractors. Well, a compressed gas is not, it's impossible. Impossible. Because remember, you cannot stop a tractor to recharge with compressed gas. Recharge a tractor with compressed gas takes 1 hour with the compressor. And what happened with the stevedore? Take out that machine, take another machine, spend a lot of time, very expensive. And the machine works without stopping 22 hours. It's aceite caliente, hot seat. So you cannot stop. Gas compressor is not an option. You need at least LNG with a big tank. Okay. I don't understand the question. What the consideration with the reefer container? No, it's always electric. No. Why? Let's see the map, the terminal map, the reefer container area. Okay. The reefers is this. No. this is the new area. Yeah, this and this area are reef. And it's very funny because something happens here. I suppose we were electrifying this area, but it's not the heaviest area, and the number of movements in river area is no so high. Why? Why? Because what it's in the average. What is the advantage of electrified river area and no other area? In this case, the heaviest area is this. Do you know why? Because this is the door area, the container that go outside, import export area. And you say, import export have the most movements in the terminal? Yes, because the keeping housekeeping, remociones. Because when you planning the operational cost, the most important, to a vessel from transborder, from one vessel to another, you can planify everything. But when you planify to a track, to an offside track, it's quite difficult to planify because the track comes when it comes. And then you have to make housekeeping. You have to move 3 containers to take the long one. And then spend a lot of energy. So it was amazing. And during the night, you don't have import-export works. These blocks, no, you don't have tracks from outside. So you have a very heavy work during the day, and during the night, nothing, no. Some movement because some containers go to vessel and come, but the most, no. Most of movement are during the day. And we can see the model, and it's very funny to see the huge difference between the shifts, between the day shift and the night shift. During the day, we move the 70 or the 80% of the energy, and during the night, only 20, 30. So you have to spend the money where you move the containers. Import export. More questions. Yeah. Or well, could be this area that is import export and used to be in terminal this area. I don't know why what happened here. I think here we have a problem with a crane this year. And one crane we take out and we have problem with this block. That is the reason this block is here. But this used to be the red area. When we start the project, I thought that the red area is going to be this. And my surprise that it was this. And what's import export? You have to take all the movements. Energy is all the movements, not not the net movement. You spend energy every time you move a container. Energy. Not significant. The energy that you waste or you waste, energy that you waste, that you use in horizontal is not too much because it's only the losses. What I try to say, when you move a container, it's expensive, but not because the energy. It's expensive because the steel. move a container like this, or by truck, or by rail. But the energy between the blocks, parallel or perpendicular, the difference is nothing in concept. The difference could be only because housekeeping. If I have to make more housekeeping, if my blocks are perpendicular or parallel, then we'll define what is the best solution. But the area is the same. It doesn't matter if it's like this or like this. The problem here is always the housekeeping and the cost. And if you have, I'm reflecting about your question. If you have an automatic terminal, it's quite expensive to move. Innovation tab, I think it's the same. Not significantly different. Because if you are perpendicular, you used to work with electrical machines. You left the container in the head, then move the RTG or RMG, move the crane, move the container very fast and return. But this machine is electrical and go over rails, so the consumption is nothing. Nothing. And if you are going to make a new machine, then sure, a new terminal, the perpendicular terminal is new. Oh, it will have energy recovery system. So a terminal with energy recovery system, automatic, perpendicular, and over rails, the consumption, nothing. The energy that is spent the terminal, nothing. Nothing. Perhaps 1% of the cost of the all activity. Because you only have the losses, and the losses in an electrical motor is 6%, 7%, nothing.
Thank you very much, for your very interesting presentation. And I will ask, sorry, the connected. You already answered some questions from our Greek students. I would like to open the floor to the other universities connected to us. If there is any question coming from any of the connected countries or from here. So if there are no questions, just once more, thank you very much for your very interesting presentation. Magnífica presentación.